Hi, I'm Peter Hull. I'm at the University of Chicago Department of Economics, and this is Towards a Non-Discriminatory Algorithm in Selected Data, joint with David Arnold and Will Dobbie. Motivation for this work is that algorithms increasingly guide many high-stakes decisions in many settings, and this has led to growing concerns about algorithmic fairness, whether equally qualified individuals, say of different races, receive systematically different treatment by the algorithm. This is a concern that is somewhat hard to bring to data in many settings because of a fundamental selection challenge. And so any qualification-based sort of fairness or discrimination measure is going to require sort of measuring qualification among individuals. But in many settings, qualification is only revealed among individuals who are selected for some treatment by an existing algorithm or human decision maker in a non-random fashion. So this paper grapples this key selection challenge in bringing this question of algorithmic fairness to data, and we do it in the pretrial setting of New York City, where we leverage the quasi-random assignment of individuals to bail judges. More generally, we show how that sort of quasi-random assignment to decision makers can be used to overcome this fundamental selection challenge. So here's just a bit of background from this famous ProPublica article in 2016, which is showing how the risk scores in pretrial systems across the country tend to be higher for Black defendants than for white defendants, which has raised this concern about algorithmic fairness. Now, to formalize this problem, let's consider a set of individuals I of different races. Let's consider their qualification, Y star, for a treatment in the bail setting. That would be whether somebody would engage in pretrial misconduct, such as a failure to appear or further criminal activity if they were released. Suppose we have some observables X, and we're interested in sort of predicting qualification from those X's. Our problem is to give the best prediction of Y star from X subject to some fairness constraint. So we want to make sure that equally qualified individuals are receiving systematically the same treatment. So we use this equalized odds notion of fairness in this paper, but our approach is going to generalize to any qualification-based constraint. The key problem, of course, is that we can't actually estimate this program because we don't observe qualifications. We don't observe the misconduct potential of individuals who are detained before trial, just those who are released before trial by a judge. And so how we're going to address the selection problem is by leveraging the quasi-random assignment of individuals to different judges. And the solution is going to proceed in two steps. The first step is to show that program on the previous slide, the challenge of selection in that setting is going to reduce to the challenge of estimating two specific vectors, capturing the relationship between the observables X and qualification Y star. Once we've simplified the program, we can show how estimating that key missing information can be accomplished by leveraging the quasi-random assignment of different decision makers in an instrumental variables framework. The key idea here, without being able to go into much details now, is that we don't need to measure individual qualification directly. We just need to use the quasi-random assignment to selection correct the relevant moments of the data. Now, what we do is we apply this in New York City, and we do this in a very simple way for a very simple algorithm, which just uses 11 features of individual demographics and criminal history. And again, we're going to sort of leverage the random assignment of bail judges to defendants, which has been used in many settings recently, both in New York City and elsewhere. Here is just a graphical illustration, which I won't have much time to go into today, of how we use the quasi-random assignment of bail judges to extrapolate out and estimate those key second moment covariances. Here I'm just estimating the true misconduct rate among white and Black individuals, selection adjusting for the fact that we only observe those among the individuals who are released by leveraging, again, this variation across the different judges. Happy to talk more about this picture with people in the discussion. Here's the end result in our setting. So these are coefficients that we put on the different features in our model. I'm showing you the selected model, which is estimated among the released defendants, the unselected model, which uses the selection correction without imposing a constraint, and the fair and unselected model, which imposes this constraint. The upshot here is that we can estimate sort of a possibility frontier among different algorithms, ones which trade off sort of efficiency in terms of root mean squared error and algorithmic discrimination in terms of our measure of equalized odds. And I think a key point here is that the selected measure, the one that's currently being used, is not only unfair, but it's inefficient. And so by correcting for selective labels, we gain both efficiency and reduce discrimination. And so that's the main takeaway. We developed this new quasi-experimental method for correcting for selection bias in qualification measures of algorithmic discrimination. This approach is very general, and we hope it can be applied in many different settings.